Industrial facility microgrids are key for optimizing energy production, offering demand flexibility, cost efficiency, sustainability, and grid resilience. In our session, you'll get to participate to understand how microgrids effectively manage energy demand in real time, and you'll get to explore the wealth of data within the system, enabling analysis of energy generation, consumption, and external grid conditions to make informed decisions regarding energy utilization. And now please welcome, with a big round of applause, Frank Helmut Wehner.
Hello, good afternoon. Welcome to this session about demand flexibility with microgrids. First of all, I would like to introduce myself a little bit. So I'm Frank Helmut Wehner. I'm working in Schneider Electric's microgrid team, helping our customers to find the right setup for microgrid solutions. Before we jump into the detail, I would like to have a short reminder of what is a microgrid. So when we talk about a microgrid, we always talk about behind-the-meter microgrids, so on end customer sites in a commercial or industrial site. Microgrids are electrical distribution systems with interconnected loads, with local production, which can be either renewable or conventional, and potentially storage, connected to the grid, off-grid, or what we call islandable, which means normally connected to the grid, and in case of grid outages, it can be disconnected. So what, from our perspective, makes a microgrid? A microgrid is the control part of it. So, and I would like to introduce to you our energy management system for microgrid called EcoStruxure Microgrid Advisor. The objective of Microgrid Advisor is to orchestrate the different energy resources on a site to achieve the best economical use of the resources. So the objective is always an economical dispatch of energy resources. Triggers are therefore always financial elements like energy tariffs, demand charges, or similar elements. So I don't want to give you a long presentation with a number of slides. I would like to jump directly to our solution, the Microgrid Advisor, which is a cloud-based solution. So only a very small amount of hardware is needed to connect a particular site to the system. So what you see here that's the starting screen of the web HMI of Microgrid Advisor. So what you see here is what we call the energy rosette, which is showing all the distributed energy resources which are connected to the Microgrid Advisor on a particular site. And what you see here is a real site. This is not a simulation, that are data coming from a real site. So what we see here is we have a utility connection, we have PV solar, which is currently producing a lot of PV power. We have a small wind turbine also producing a little bit of power. We have a battery storage. We have some EV chargers. We have an HVAC system from the building and the remaining electrical loads which are covered here. And what you can see on this first diagram is the current situation. That means how much energy is produced from PV, how much energy is produced from wind, what is consumed by the HVAC system, and finally, how many power do we consume from the grid, or in this case, you see the direction is to the grid. Currently we are doing export of energy to the grid. So the second thing you see on the right side is some basic KPIs. So for example, currently you can see how many power we do export to the grid. And you see there is also a limit of 650 kilowatt given. That's the maximum export we can do. If we exceed the 650 kilowatt, we have to take some measures to avoid further and higher export. Secondly, you see the tariff rate. That means that's the price of energy we are currently paying. And you see there is a tendency, so in the next period, we will see it in a minute, we will have a lower price. And finally, you see weather forecast data. Weather forecast data are very important because what Microgrid Advisor is doing, it's forecasting the consumption and production in the next 24 hours. So let's move to something that's maybe a little bit more impressive than this one, because this looks quite static. What you see here is a time series of data with different elements. So on top you see the energy prices, and here you see we have a certain price during the day and a lower price during the night. In future, this might be even a dynamic curve with dynamic prices. So on the second graph, you see two curves, a black curve, which is showing the consumption of the site in total, so the loads of the site, and the blue curve is showing what we are consuming from the grid. In the third row, you see two curves, a yellow curve that shows the local production, and the green curve that's showing the use of the battery storage. So what you can see here is that currently, due to the PV production, we have reduced the grid consumption very much, or we are even exporting. So here you have a timestamp, which is the current point in time. Everything on the left side from that timestamp has happened in the past. So the solid line shows what has actually happened, and the dashed line shows what has been predicted. So everything on the right side, that's the forecast for the next 24 hours. This forecast is updated every 15 minutes, so that's a kind of rolling forecast, which allows us also to register any parting changes. So what you can see here is that we will charge the battery with the surplus from the PV, as long as the PV production is higher than the consumption. When the production is going down, we might discharge the battery, so we use the stored power, the stored capacity coming from the surplus of PV. This mechanism is called the maximization of renewable self-consumption. So we maximize the use of our PV production, and with that we reduce our energy bill and the sustainability footprint. And finally, what you see here is during the night, when the energy tariff is lower than during the day, we charge the battery again. And why we are doing that? Because in the morning hours, when the tariff is already going up, but the PV is not yet there, we can discharge the battery again, and with that we can reduce the grid consumption. And again, this is a matter of how we can save money with our resources. Just as an example, we have done one project in Australia where the difference between the normal price level and the high price level is approximately with a factor of 10. So it makes really sense to use the battery during low prices. And what is very nice is during the night there could be periods where the price is even negative. So what would be more clever than charging the battery during that period of time and use this stored capacity during the high price period during the day? That's exactly what we are doing, and that is how we help the customer to optimize his energy bill. So what you see here is the picture of the complete site. But we can have a look on each individual decentralized energy resource as well. So for example, we could have a look on the battery storage. Here we see what is the current state, and we can, if we click here, we can see also the time series for that. When we plan to charge, when we plan to discharge, what will be the status of charge of the battery storage. So all these data can be seen on that diagrams. So that is what I showed you until now, is what we call the real-time view. That means that's currently active. But we can also look into the past. And for example, let's have a look on what has happened last month. And here you see again the energy rosette that we have seen before. And we see what is the energy that has been produced or consumed by each of the individual DERs. So we see we had roughly 50 megawatt hours from solar. We had roughly 5.5 megawatt hours consumption from HVAC. And on the right side, that's also sometimes really interesting to see which portion the individual DERs has either been provided as from the production point of view, or where has been energy consumption from the load side, respectively, what is the amount of power that we have re-injected. And finally, you see in the middle a chart which is showing you the energy cost and the energy savings. And if you take the sum of both, that would be the amount of cost that you would have had without EcoStruxure Microgrid Advisor. So it gives you a very good overview of how much money you can save with the orchestration of the energy management system EcoStruxure Microgrid Advisor. So finally, you may want to use data from the platform to do further analysis. And you can do that. If you go to the export data segment here, you will become a list of data that you can extract either from a site level or from the individual DER. And you can also select a period of time from which you want to extract the data. And once you have done that, you will get a set of CSV files which you can simply download and use it, for example, in an Excel sheet to do further analysis from your site. So, going back, that was a very brief introduction into the capabilities of EcoStruxure Microgrid Advisor. I know it's maybe not that deep as it could be, but I think it gives you a very good view on what you can achieve and how Microgrid Advisor can help you to monetize your DERs in a much better way and to help you to do energy cost efficiency increase and improvement of your sustainability footprint. So thank you very much for your attention, and I'm happy to answer your questions.